Hello everybody, this is Mark Brockman and I'm going to give a short lesson in what I call supercharging the slider bar. So I'm sure we've all used Desmos to graph a simple equation like a equation for a vertex form parabola, x minus h squared plus k. And then Desmos puts up all these options to create slider bars for all those variables. And so you just click all and you get all these variables, easily allowing you to see what the effect of changing those variables are. So if you start changing a, it thins it out, makes it wider, and when it goes negative, it actually flips over the x-axis. The effect of h is the vertex x-coordinate, so you can slide it around and it moves the vertex back and forth along the x-axis. So if we stop at 2, for example, and then k is the y-coordinate of the vertex, and so it slides it up and down, okay? So there we have a nice looking little parabola. So now I start thinking, well, what about a line? I can do the same thing. So I'm going to type in this equation for the standard slope-intercept form of a line. Y equals mx plus b. And of course, Desmos gives us an option to add a slider for the slope and the y-intercept. So you start playing with the y-intercept and it moves up and down. That's great. So let's stop at 3. And then the y-intercept at 3. And so the slope moves it up and down, and you can see it spinning around there. And all of a sudden I find a point where, it looks like it's perfectly tangent to the parabola. And I think, this is great. I've now found a way to create a line that's tangent to that parabola. But then you start zooming in, and you realize that it's not tangent at all. It doesn't even touch the parabola. So that got me thinking about tangent at a point to a curve. So we all know from calculus, if you take the first derivative of the equation of a parabola, it gives you the slope of the line, the slope of the parabola at a particular point. That's exactly what we want in this case, is the tangent line to be at a particular point. And so first thing I did was I'm going to choose a line. So slope and y-intercept for a line, and of course it's got slider bars, so we can actually make that anything we want. And so there's a line. And so now I started thinking I want to choose the x-coordinate of the tangent point, and that fixes the y-coordinate, because the line is already set. And so I choose a point, put a little label on it, so right there. So now I'm saying I want to create a parabola that touches the line right there. It's a tangent point to that parabola right there at that line. So now all I need is the parabola. And so I started thinking about it, and it was like, really, all I need to do is choose the x-coordinate of the vertex, because the x-coordinate and the x-coordinate of the vertex and that tangent line are actually going to be related. So I choose a vertex point of 8 and do a little bit of algebra and a little bit of calculus, and eliminate the variables b and a, or actually create the variables b and a, and I wind up with the standard form equation of a parabola, y equals ax squared plus bx plus c, and sure enough, it goes through that tangent point. And just for illustration purposes, I put the x-coordinate, I'm going to put the actual coordinates of the vertex of the parabola right there. Now, the fact that we've done all this solving symbolically, I haven't created a single parabola. There's just a single case here for a, b, and c being these variables. But since I've created them symbolically, I can now use the slider bar to see what effect it has on this pairing of the tangent and the parabola. And so if I start sliding around the slope, well, my parabola changes to keep the tangent point right there at the same x-coordinate that I wanted. So I can slide the slope around and it changes the parabola. I can slide the x-intercept up and down, and sure enough, all that it does is raise the parabola up and down to keep it tangent right there. And so then I started thinking about, well, what about if I change the x-coordinate of the tangent point, what's going to happen? And I would expect it to slide along this line. And this is where pushing the play button really has some nice effects. you can see that as that tangent point slides up and down the line, the parabola has to change in order to keep it a tangent point right there with the x-coordinate of the vertex where I specified earlier. And so if I decide to change the coordinate of the vertex, the x-coordinate of the vertex, have it get animated, you can see that it moves the parabola around. And the interesting thing about that, to me, is it looks like maybe this is following a line, and I would really like to figure out what the equation of the line is at some point. So that really shows you that you can use the slider bars and the play button to do a lot more than just animate a single variable. As a matter of fact, I would expect that if I, let's see if I can skinny this up a little bit, if I hit both play buttons at the same time, that means they'll be moving at the same rate. So if the x-coordinates are moving at the same rate, then all that should happen would be this parabola just moves up and down. So I hit that play button and move over and hit that play button, and then move over and hit this play button, and sure enough, the parabola just starts sliding up and down. Now there's a little transition point where it has to flip upside down, but you can see there that it's moving both those variables at the same time. And so that's what I like to use Desmos for, especially the slider bar and the play button, is to really symbolically define some kind of a scenario and then see what happens to all the different players in the scenario when I hit the play button, and thus supercharging your slider bar.